Hello and welcome to part 4 of the PressurePro tutorial. We now have a project with overburden created and a shale pick defined. In this tutorial we will jump straight through to building a pore pressure model and then come back to do the fracture gradient. Open the pore pressure dialog box and select the pore pressure option. Click on the Add button to add a new model. The pore pressure models are displayed as tree structures with all the required elements. To build the model, start at the top and work down, double-clicking in the cells to edit. The name defaults to PP and a number according to the model. This can be changed if desired. The second element is the model type. We will be building a sonic model, but in here we can select resistivity, d-exponent, a user-defined equation, and also a simple picked method. The model option allows the selection of either Eaton or Bowers methods, which are embedded in the software. For other model types, simply select the equation option in the model type and type the equations in. The curve is where we select the desired curve to use. In this case, we will be using the compression or sonic curve. Note that when the curve is selected, the shale points will highlight on that curve in the log plot. The regional NCT option is only used if you wish to pick the compaction trend for an area by overlaying multiple curves on the same plot. If using a single compaction trend, as we will here, double-click in the NCT option to open the normal compaction trend dialog box. Settings on the left allow customization, but the most commonly used is the shale pick cropping. Click here and select the points option. This will remove all the sonic data that does not correspond to a shale point. Use the yellow circles to move the compaction trend line, noting that you can see the overall trend on the log in the background. Additional compaction trends can be added if desired by double-clicking on the log in the NCT dialog box and selecting Add Section. Double-clicking within either section activates it for editing. Once done, click Close. The rest of the tree comprises the customization of the Eaton exponent, NCT line color, which shale pick model to apply, and a buoyancy model if desired. Now we have all the elements of the pore pressure model. We apply our overburden curve to the model by clicking the Add button. A filter button allows us to add a smoothing function to the pore pressure curve to remove the high frequency noise. Our next step will be the fracture gradient. Click on the fracture gradient button. On the left side of the dialog box, we now have a button to allow the entry of leak-off tests. Click on the button and add a leak-off test. Let's just add a leak-off test of 12.5 ppg at 800 meters and close the dialog box. Check the leak-off test checkbox to show the marker on the plots. We have a full compressional and shear data set as well, so we will now create a Poisson's ratio curve. Click on the True Poisson's ratio option and enable the calculation. Select the compressional and shear curves to be used and apply. We will now add two different fracture gradient models. Click on the Add button and select the Eaton method option and the leak-off tests as the source. Now add a second model and select an Eaton Poisson's ratio method and select the Poisson's ratio curve as source and select the actual curve. This assigns all the properties required to generate two fracture gradient models. Click on the pore pressure button and notice that under the overburden element applied to the pore pressure model, we have the option to add fracture gradients. Click on the Add button twice to add both models for comparison. Curve colors and line style can be changed from here for easier viewing so that we can differentiate between the two models. We can also make manual edits. Pore pressure and fracture gradient models are often going to show slightly erroneous trends which can be identified with other indicators such as caliper logs and connection gases. The pore pressure can be manually adjusted by clicking the Manual Edits button and forcing the values to a specific number. The fracture gradient can also be bulk shifted to calibrate to leak-off tests. Click on the Correct button and shift the curve as required. In situations where multiple models are being run for multiple sources, such as resistivity, sonic and d-exponent models, the pore pressure and fracture gradient curves will differ. If wanting to interpret an actual pore pressure and fracture gradient from the various curves to provide a single interpretation, we can add a picked model. Add a new model and select the picked option in the model type. Now click on the Pick button and zoom out on the log. A black line with green circles will appear on the plot. More green circles are added by double-clicking, and they can be dragged around to adjust the interpretation. Once finished, click on the Done button in the dialog box. This curve can obviously be filtered and smoothed to create a more realistic curve. This completes the pore pressure model building process.